you doing this morning or this afternoon, ladies and gentlemen, boys and girls, friends and neighbors? Back today with a few examples from A.6, solving equations. We're going to solve linear equations, super easy. I am not reviewing solving the linear equations. The first few problems from this section are super easy. Pre-algebra, algebra problems, you should be able to do those. We will be looking at some quadratic equations, some absolute value equations, and I think maybe another type of equation. So let's begin reviewing some problems from A6. Let's look at this guy. We will not look at linear equations, just like I said. We will look at that guy right there, and that appears to be a quadratic equation. It is going to be a quadratic equation because if you did multiply this out, you're going to have x squared here, and you multiply it out, it's going to have an x squared there. So that's what we're going to start doing, is multiplying out. We're going to multiply this and multiply that. Usually to solve a quadratic, you're going to set it equal to 0. But something magical happens here. If I multiply this out, x plus 3 times x minus 2, using the distributive property, you're going to get x squared plus x minus 6. If I multiply this out, this is not x squared plus 4, ladies and gentlemen, boys and girls. This guy right here is x plus 2 times x plus 2, which happens to be x squared plus 4x plus 4. Now what I'm going to do is, I can see that there's an x squared here and an x squared here. So what I'm going to do is I'm going to subtract x squared from both sides, and now I'm down to a linear equation, which is super easy. I think, what do? I'm going to subtract x from both sides. This is work that you do not need to show. If we were in algebra, you would want to show this work, but we're not in algebra. This is like pre-calculus. So we're going to subtract the x, get 3x, and now we have negative 6 is equal to 3x plus 4. Subtract 4. Negative 10 is equal to 3x. X is equal to negative 10 thirds. Thank you very much. Enough of that. Let's go on to another example. Let's go to this guy right here. Let's go to an absolute value equation. Whoa! Right there. The absolute value of 3x minus 5 is equal to, 3x minus 7 is equal to 5. How about that, Stevie Wonder? That's good stuff, isn't it? Yes, it is. Yes, it is. Can't wait to be back. We'll do a little history of rock and roll right there. Also, along with some math, along with some social studies. We'll be talking about a lot of social studies this year as the year progresses. How about this? The absolute value of 3x minus 7 is equal to 5. Oh, how do you do that? Oh, I don't know. Well, here's how you're going to do it. Before we do that, I want you to look at this guy right here. The absolute value of x is equal to 2. What does that mean graphically, geometrically? What does it mean? The absolute value of x is equal to 2. It's equation. It's asking us a question. The question it is asking us is what numbers, absolute value by definition, by formal definition, is how far a number is from 0. How many units it is from 0. So this is asking the question, give me all the numbers, because x is a variable, give me all the numbers 2 units from 0. Well, we know all the numbers 2 units from 0. 2 and negative 2. What do you mean? I mean that if I have a number line, negative 2, negative 1, 0, 1, 2, negative 2 and 2 both are 2 units from 0. So that's why this equation, absolute value of x is equal to 2, is the solution to that equation is x is equal to negative 2, or, it's a disjunction, it's an or thingamajiggy, or x is equal to 2. Let's expand that thought for a moment, and let's look at, hey, the absolute value of smiley face is equal to 4. What does that mean? What question is that asking? That is asking us a question. What question is it that it is asking us? You're right. It is asking us what smiley faces are 4 units from 0. Well, when smiley face, what smiley faces are 4 units from 0? Well, what do you mean? I mean, smiley face could be negative 4 from, if smiley face was equal to negative 4, that smiley face would be 4 units from 0, right? Smiley face is equal to negative 4, or smiley face is equal to 4. Both of those guys here, both of those smiley faces are 4 units from 0. And that's what this is asking us. It's a question. So whenever you have an absolute value of a linear, if smiley face is linear, we'll talk about it if smiley face is quadratic, or if smiley face is another degreed algebraic expression, degreed polynomial, or anything really. That's for down the road. But not all the time, but 90% of the time, if you have an absolute value equation, there's going to be 2 answers. 9% of the time. So let's go back to our original equation. Question then. Oh, whoop, that was the original question. Smiley face here, in this case, is 3x minus 7. And I'm certain that the smiley face is something that you're not familiar with. If I'm going too fast, hey, what can you do? Shh, pause the video. Okay, pause it. But look, simple question. How many things, what things are 5 units from 0? Well, 3x minus 7, if that was equal to negative 5, that guy is 5 units from 0. And this guy is 5 units from 0. Because that's the question. This is asking us a question. What things are 5 from 0? Well, that thing is equal to negative 5. Those things are 5 units from 0. And those things are 5 units from 0. That's why you have those 2 separate equations. And blah, blah, blah. Now they're linear equations. I'm not going to review them. There's the answer at 7. Blah, 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 blah. There's your answer. So there's 2 solutions to that absolute value equation. 2/3 and 4. Both of them work. Okay? Important. Absolute value equations are important. Let's go to another type. You want to? Let's... Hold on there, Roy. Let's go to this guy right here. Oh, that appears to be linear, but it is not. That also is a quadratic equation. You saw many of these in Algebra 2. The first thing I would do is distribute the x and verify that it is indeed an Algebra 2 equation. And if you multiply through by the x, you're going to get x squared minus 7x is equal to negative 12. How do you solve a quadratic? You set it equal to 0. You solve a quadratic by setting it equal to 0, ladies and gentlemen. Add the negative 12. X squared minus 7x plus 12 is equal to 0. Now, how do you solve it? Well, you could factor it. Maybe you can factor it. If you have a quadratic, not all quadratics factor. Only the nice ones factor. This happens to be a nice one. But what method, what formula can you use to solve any and all quadratics? You are absolutely correct. You can use the quadratic formula. That always works. That works for every quadratic. That works to solve every quadratic. But if you can recognize right at the beginning that it's factorable, I would try to factor it first. Or use a quadratic formula. I don't care. But this one, it factors really easy. So let's just factor this rascal. You want to? Yes, I want to. Bam, bam, right here. Oh, why do you keep doing that? I don't know. This one factors easy. X minus 3, x minus 4. Hello? Come in. Yes. X minus 3 times x minus 4 is equal to 0. Now I'm going to use a zero product property. I have A times B is 0. What does that mean? This factor, what does it mean? A times B is 0. That means that A is 0, or x minus 3, or B is 0, or x minus 4. Again, 2 simple linears. This says that x is equal to 3, x is equal to 4, and if you tried either of those, they both are going to solve that quadratic equations. That quadratic equation will be 3 or 4. And there will be problems assigned in this section, ladies and gentlemen, that do not factor, that you will have to review, and if you look and read ahead, you can review the quadratic formula, okay, which is something that's nice to know. Hey, here's one more example from this section. It's a little hint that we're going to do a lot next year, not so much this year, but we will do it this year. We're going to do it right now, actually. And this is that guy right here. 2 times a quantity, s plus 1 squared, minus 5 times quantity s plus 1 is equal to 3. That's quadratic in the variable s. Yes, it is. You could multiply this through s plus 1 squared, s squared plus 2s plus 1, and multiply that, make it quadratic in s, subtract the 3 and solve that. But here's a hint that I want you to be able to do, and there's 3 problems on the homework set that I want you to do this way. We are going to use what we call, and this is going to be new for you, this is not a review, this is new. Okay, I'm certain that they didn't do this last year in algebra, I'm certain of it. But we're going to use U substitution, something that's very prevalent in the world of calculus, U substitutions. That equation is not only quadratic in S, ladies and gentlemen, that's quadratic in S plus 1. So if you look, and it should jump right out and slap you across the face, what the U substitution is going to be. And you'll have to get it, the more of these you do, the easier they will become. But what I'm going to do is let U equal S plus 1. Oh, and you can do that, ladies and gentlemen. You can do that. Yes, you can. I'm going to let U equal S plus 1. And now I'm going to have a simple equation in U. I'm going to have 2u squared minus 5u minus 3 is equal to 0. Keep in mind I subtracted that 3 from both sides up there. But now I have a simple quadratic in U. One that factors. And I'm going to factor that rascal, 2u plus 1, u minus 3. And you could use the AC method, but like I said, this is one that you, at this point, you should be able to see very quickly that this thing factors to 2u plus 1, u minus 3. If not, you can do the AC method, and you can use the AC method and factor it like we did a couple days ago. You know, AC is -6 and PQ and all that. But this is going to be your factorization. I challenge you to do the factorization over there. But now I have the zero product property. This times this is 0 says that this guy is 0, or this is 0. So I have 2u plus 1 is 0, or u minus 3 is 0. That says, simple linear, that u is equal to -1/2, or u is equal to 3. So that's the solution of the equation. Right, Johnny? No, you're not right, Johnny. Because that's not the solution I wanted. What did I originally want? I originally wanted the solution to this equation. I wanted to know what S was. Well, I let u equal S plus 1. Now I know what u equals. U is -1/2 or u is 3. So what I'm going to do is, u is S plus 1 is equal to -1/2. Solve that. S plus 1 is equal to 3. Subtract 1. S is -3/2. Subtract 1. S is 2. And now I challenge you that this is the solution to this original equation. Put those guys in there and you're going to see that they work. Okay. So this is a short example of a few of the assignments from A.6. Solving equations, very important. I will see you soon, ladies and gentlemen.